I will present about introduction aluminium. Okay, aluminium is the world most abundant metal and is the third most common elements, comprising 8% of the Earth's crust. The versatility of aluminium make it the most widely used metal after steel. Then although aluminium compounds have been used for thousands of years, aluminium metal was first produced around 170 years ago. Pure aluminium is soft, ductile, corrosion resistant, and has a high electrical conductivity. Is the widely used for full and conductor cables, but alloying with other elements is necessary to provide the higher strength needed for other applications. Aluminium is one of the lightest engineering metal, having a strength to weight ratio solid to steel. By utilizing various combination of its advantageous properties such as strength, lightness, corrosion resistance, recyclability, and formability. Aluminium is being employed in every increasing number of applications. This array of produce range for structural materials to the packaging food. I will present about detailed manufacturing step in die casting. Two types of die casting machine. Number one is hot chamber die casting machine. Number two is cool chamber die casting machine. Detailed manufacturing step in die casting. The high pressure die casting process consists of 4 steps, including mold preparation, filling, injection, and check out. Process number one is in the preparation process. It is necessary to spray a lubricant into the cavity. In addition to helping to control the temperature of the mold, the lubricant also help removing the casting, and then the mold can be closed. Process number two is filling. The molten metal is filled into the mold with high pressure, which is the range of about 10 to 175 MPa. When the molten metal is filled, the pressure is maintained until the casting solidifies. Process number 3 is injection. The die of the open and the short are different from casting because they can be multi-cavities. In a die welding, multi-casting workshop is ejected by the injector pin. Process number 3, the last one, is check out. The process of check out requires separating the scrap, including gates, runner, spoolie, and splash. This process is usually done by extruding the casting towards a special dressing die, or others send fill fillings methods including sewing and braiding. Lastly, defect inspection. Defect can check after the checkout process is complete. The most common defect include stagnation and cool heading. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Karima binti Cik Abdul Halim. My matric number TA19160. Today I'm going to talk about justification of our metal that we choose as a casting. So we choose aluminium. Okay, what is the benefit of aluminium in die casting industries? Okay, first is one of the most significant benefit of aluminium in die casting. It creates a lighter part with more surface finishing option than other die cast alloy. Aluminium can also withstand the highest operating temperature of all die cast alloy. Moreover, cast aluminium is corrosion resistant. It retains high dimensional stability with thin wall and can be used in almost any industry. Okay, next is for the die casting mass production. Aluminium casting method can produce from 1,000 to 1 million unit per year, and that was a huge amount. And with aluminium also, it can have a fast production, high surface quality, low porosity, high dimensional accuracy, and dies last longer than other kind of mold. Okay, for the cost of die casting using aluminium, more efficient than alternative process. Okay, next is I'm going to talk about market value of aluminium casting. Okay, according to Transparency Market Research, the Asia Pacific region account for over the half the share in the global market for aluminium casting. In the year ahead, the region is expected to further increase its share by pulling in the maximum compound annual growth rate of 5.3% during the forecast period between 2017 and 2025. And the powerhouse of China taking most of the credit, this market region is expected to become $22.67 by 2025. Another important driving force includes the region of Europe and North America in the global market for aluminium casting. While Europe is expected to register a compound annual growth rate of 5.1% during the forecast period to become worth $9.45 by the North America region is expected to rise at a compound annual growth rate of 4.9% to become worth $4.22 by the end of the year of 2025. The statistics provided in this article express the importance in future aluminium die casting growth for global production needs. And that's all from me. Thank you so much. Goodbye.
Assalamualaikum and good day. My name is Anisha Kira binti Sukairi. My ID number is TA19124. So I'm gonna explain about my point, which is the properties of aluminium. Aluminium have two main properties, which is physical properties and mechanical properties. So I'm gonna show the table to the physical properties and mechanical properties. Okay, so I'm gonna start with the physical properties of an aluminium. So the first one is the density. The density of an aluminium is around 2.70 gram per centimeter cubic, which is one-third density if it's a steel. It is also excellent electric and heat conductor, and also a great resistant to oxidation and corrosion. It is also non-toxic and can be recycled with only about 5% of the energy that was needed to make it from aluminium. And lastly, the melting temperature of an aluminium is 660 degrees Celsius, which is relatively low for a metal. But aluminium does not perform well at an elevated temperature. Okay, the second one I'm going to explain about the mechanical properties of an aluminium. So the tensile strength of aluminium is around 90 megapascal to 200 megapascal. And then the Young modulus or the stiffness of an aluminium is around 70 gigapascal. But an aluminium is low hardness and have a poor wear resistance. Then after that, I'm gonna explain about the some example for phase diagram, which is aluminium silicon phase diagram. Okay, this is some example of phase diagram for aluminium silicon, which always used for die casting. So the figure show that this phase diagram have an eutectic points at 12.6 wave percentage, and the temperature is at 577 degrees Celsius. We can also tell that the aluminium dissolve a maximum of 1.6 wave percentage of silicon, while the solubility of aluminium in silicon is almost zero. The eutectic alloy provide a natural composite which give good properties for the alloy. For example, the commercial aluminium alloy often contain other alloying elements such as magnesium or copper in addition to the silicon. Okay, there is three types of improvement that can be done toward aluminium. First is hardening, second is softening, and third is surface. So for hardening, it got two types. First is precipitation hardening, second is strain hardening. So for the precipitation hardening, it using heat treatment to produce uniformly dispersed particle within grain structure. This particle hinder dislocation, motion, thus strengthen the metal. And second, it got three stages. The first stage is solidization, which the aluminum alloy are heat into a single phase solid solution. At this stage, the alloying constituent are assimilated completely into the crystal structure of the host material. Second stage is the quenching. The quenching is structure of the single phase of solid solution is then retained by a rapid cooling. And the third is aging. The aging is a subtaining heat treatment at lower temperature, allow for a controlled precipitation of a constituent. And for the strain hardening, the dislocation disrupt the perfection of the crystal structure, which increase the strength of the material. And the dislocation of density can be shown to increase as we strain or deform a material. The second one is softening. Softening is carried by annealing, where the annealing is applied to promote softening by its carried out in the range of 300 to 440 degrees Celsius, and the heating time at the temperature vary from 0.5 to 3 hours. Annealing means the metal being heated and allow it to cool slowly in order to remove internal stress and toughen it. After that, quenching is carried out after the annealing. So the objective of the quench is to ensure that the dissolved steel being part of the remains solution down to room temperature. And the third is surface or surface treatment. The surface treatment is done for corrosion resistant. It involving anodizing and hard coating. A coating is an aluminium oxide and electrochemically induced. The coating provides a good corrosion barrier and wear resistance. A pure aluminium has a better corrosion resistance than any of the aluminium alloy. This is because of the alloy micro-constituent impair the protective oxide film. And lastly, to improve the corrosion resistance, aluminium, copper, and aluminium, zinc, magnesium alloy are sandwiched between two pure aluminium sheets and rolled to produce a composite called aluminium clad.